Now that we have our project directories all set up and we've created our MySQL database, we're ready to start building the foundations of our object-oriented project, the photo gallery. And we're going to start doing that by taking a look at the MySQL database class. The idea here is to take everything we learned about connecting to databases from the essential training and apply what we've learned about object-oriented programming to it. Let's start by taking a look at those steps that we learned in the essential training. The very first step is that we'll require the config file that has those constants defined in it. And then we have 5 basic steps. We're going to create a database connection, select the database we want to use, then perform the database query, use the return data from that query, and then close the connection. Steps 1, 2, and 5 will be the same for our entire project. It's really steps 3 and 4 that will vary from page to page. And we saw that also in the essential training. Now let's see how we can put these into an object. I'm going to start by creating a new file, and we're going to save it in our includes directory as database.php. And let's just open this up a little bigger, and we'll just put it over here so that we can see both at once. Now, we know that we still are going to want to do this require, right? That hasn't changed at all. And that'll happen even before we define our class, which will be MySQL database. Now, you might be wondering why I went ahead and called it MySQL database and not just simply database. Well, we could. But my thinking here is that if we had a different class for every database, then it would be really easy for us to swap out databases. So let's go ahead and when we're done, we're going to instantiate database equals new MySQL database. That's the idea. That's what we're going for here. And that way, database is ready to go, ready for me to use. As soon as this file is done, it will not only define the class, but create a new database and assign it to database. And if I, for example, want to change it someday, I can have another one that is my Oracle database, or another one that is my MS SQL database, for example. But for now, we're just going to use MySQL, but we already have that sort of modularity built in. And we could even have something that looks in a config file to decide which one of my database adapters should I use. So I think this is just a good programming technique. Now let's start by taking step 1 here, and let's think about how we could put that into our object. I'll just copy it. And we're going to need to put it inside a method, right? So let's go ahead and say function, and let's call it simply open connection. And let's paste all of that we just had in there. We don't need this 1 anymore. And I'll go ahead and move this over and expand it a little bit so we can see a little better. There we go. So now we should be able to call database open connection, and it would open the connection for us. That's what we're going for. So this has got to be a public function. We saw that. And there's a couple more things we need to do, though, because just opening the connection doesn't do much. This sets a local variable connection equal to the connection, but then we don't have access to it. So this is where we're going to need our attributes. So let's say we're going to have an attribute here. We'll make it private, and we'll call it connection. And that is where we will store our connection. So we know then that we have to change these to refer to the instance variable, this connection. So now it will create the connection for us and then assign it to that attribute. So now whenever we want to talk about the connection, we can refer to it as database connection and then do whatever we want with that connection, except that it's private. So we're going to need another way to access it. The same idea as the bank vault and the bank teller that we talked about. But we've done a good thing by storing it because now it's part of the object and that connection is held on to. Now you may be thinking, isn't there an easier way to do these 2 steps, right? I mean, we learned about the construct method, and sure enough, if we do function construct, we can open the connection automatically. So now we don't even need this step. As soon as we create the database object, it creates the connection for us. So we can already start to see how we're going to put all of these database connection parts into our object. Let's fold these up, and now let's try creating another one here for public function close connection. And that should be obvious enough. We'll just come down here and grab these from step 5. And of course, we're not looking at just connection anymore. Now we're looking at this connection, the attribute. So there we are. Now we've brought in close connection. So that's all there really is to taking those kinds of functions and putting them into an object. And now we have the ability, if we wanted to say database, close connection, now it will open the connection when it creates it, then in the next step it will close it. And it will still be able to find the connection because it's held in that instance variable. Now before we leave this, once we open the connection, we also know that we're always going to want to do this step 2 here. That's going to happen every time. So let's go ahead and copy that, and let's go ahead and perform that at the same time. I'm going to put it in an else statement. So if there's no connection, then die. But if there is a connection, then go ahead and select the database. This connection, right? I'll just need to make that little change. And if there's not a database selected, then die also. But if there is, then just keep going. So now we have both our open and our close connections. I'm going to go ahead and take this out because we don't want to close it. We're going to want to keep it open because now this is available to us. All we need to do is refer to the object database on any page that has included this database.php file, and we have full access to our database. You may want to call this just DB. That's very common. Or we also saw that you could do DB equals and database, and that will point it to the reference. And you could also refer to that same MySQL database object by just using DB. I'm going to use database all the time, but I'll go ahead and leave it there just so that you have it. In the next movie, we'll continue building our database class by looking at how we can put in step 3. In this movie, I want to take a look at how we can get our MySQL database class to actually perform database queries for us. Specifically, I want to focus on step 3 out of our 5 connections on performing the database query. The SQL is going to change each and every time on different pages. We're going to want to run SQL on different tables. We're going to want to ask for different things. We're going to want to do inserts and deletes. But this part here is the same every time. We're just simply doing a query, getting the result back, and making sure the result exists. So let's take that and put it in our class. I'll just copy it and paste it over here in our class. I'll go down here and we'll make public function query. And of course, we're going to pass in SQL. And then let's just paste in that same code we were working with. Now we know we're going to need to ask for the connection as the attribute from the MySQL database class. And then the one other change we're going to need to make here is, of course, if there's not a result, die. But otherwise, we want to return the result. It doesn't do us any good if we just run the query and then nothing happens. We want to be able to return it out of the object, and then we'll be able to catch it into a variable. And then we'll be able to work with those results. Now in the essential training, we also had a couple of other helper methods that we were using to help us interact with databases. Confirm query was one of them. I'm going to go ahead and bring that over into our class. And you'll see that it does the same thing that was being done up here. So we can actually take all of this now that we have a new method for it and reduce it down to just confirm query, and then we'll pass it in the result. Now this can actually be a private method because it's not something we need to be able to call from outside the class. The class just needs to be able to confirm that the queries worked. Now if you ever came up with a case where you did want to be able to do it, you could make it into something public. I'm just going to change this also from result set to just result. I think that's just a little cleaner. And then the other one that we were working with before was this MySQL prep. If you either didn't do the essential training or if you don't have access to that code again, go ahead and pause your movie, copy this down, but remember what it does is it prepares values for submission to SQL. And it does that by doing some checking to figure out whether or not magic quotes has been set, whether or not we have access to MySQL real escape string, and then it does some processing on the value that we submit. So it's a good way to just make sure our values are clean and ready to go to SQL. So I'm going to copy that one as well, and I'll close that up. And let's put that one up here, MySQL prep. Even though we don't have a place that we're going to use it just yet, we can see right away that it makes a lot of sense for us to have any code related to MySQL be inside our database class. We're grouping our code so it's easy to know where to find it. We don't have to wonder which one of our function files is it in. It's in our database file. It makes it easy to find. And then we can modify this later if we need to. And I'll go ahead for now and let's make it public. So now we have the majority of the parts that we were working with in the essential training rolled into our database class. And we can simply call query on some SQL, and it'll take care of the rest for us. So let's try that out in the next movie and make sure that our database class is working and troubleshoot any problems that we run into. Now that we have a database object that's able to open connections and perform queries, we need to try it out and make sure that it's all working. To just do that in a really rough way, open up index.php and we'll put some code here so that we can try it out. Now the first thing that we need to do is we need to load in our database code. Now if you look over here at the directory structure, you'll see that index.php is the file that I'm working in. That's inside public. I need to go back a directory so that I can then go inside includes and load up database.php. And we'll do that with require once and .. / includes database.php. that will load in the database file. So that will define my class, and it will instantiate the database variable for us so that we can work with it. And we can just test that real quick by doing a simple if database is set, echo true, if not, echo false. So that's the only thing that's happening on this page, is that it loads in database. So there's no other way that it could be set. Let's just try that. I'll go into Firefox, and for me, that's going to be localhost, and then inside ~Kevin/photo gallery public. That's where we want to be, index.php. Now, you may not need to put the index.php if your server is set up to automatically serve PHP index pages. And if you're on Windows, of course, you won't need to put in the ~Kevin at the beginning. But we can see that the result is true. That's the important part, is that it came back and it said, yes, it was set. Great. So let me just switch back now to index.php. Let's try one of our other methods. Instead of echo, is this working? I'm going to try echo and then ask our database object that we've created to run its MySQL prep method. And it's going to run it on a string. That's what it does, right? It works on values. So it's just a simple string, and it's working, question mark with the BR after it. Now, the important part is this apostrophe. SQL doesn't like apostrophes because it uses apostrophes when it's constructing its values, and that's what we need to escape. So what we're wanting to see is that apostrophe, does it get escaped? So let's just save that, switch back to Firefox, and sure enough, there's the slash in front of it, which makes it acceptable for SQL, and we can now use that. That value has been rendered safe for us. So those are the most basic tests we can perform. We made sure that the object was loaded in successfully, no problems there. Instantiated to a variable, so we saw the database is set, and we were able to call one of the methods on there. So we're able to see that that method works. So we know our basic object is working. If not, go back and double check, make sure that all your parentheses and brackets and everything are all closed properly and that there weren't any errors in there. This is your chance to troubleshoot. But I'm going to keep moving, and I'm going to go ahead and try doing some SQL. Let me just open this a little wider. And I've just got some real basic SQL to insert into my users table the values, ID, username, password, first name, last name, and the values will be 1, and then the string for my username, which I'm just going to make K Skoglund. You can make it whatever you like. My password, I've made just secret PWD, and then my first name and last name. You can put in yours. And then all I'm doing is telling the database, run that query. That should perform the insert. Now, normally when we do inserts, we do more error checking to make sure it was inserted and everything. Right now, I'm just doing a really primitive check to see, did it work? And one way that we can test that without going into phpMyAdmin is just to search for that value and see if it's there. So run another SQL statement, select from users where ID equals 1, tell the database object to run its query method on that SQL. It's going to set the variable result set equal to the value that's returned. Remember, we had it return a value back to us. And then it's going to run MySQL fetch array on that result set to get the first user, and then from that user, return the username. Let's try it. Now, I'm just going to run this once because I want to insert into the database only once. And there it is. It worked. Now, if I try it again, you'll notice that I get a database query problem, because it isn't able to insert it into the same ID multiple times. So if you ran into problems there, you'll want to go into MySQL and remove that entry and then try again. Or you can simply take these 3 lines here and comment them out so that we only insert in one time. And after that, it runs without a problem, and we can make sure that we're getting back users. So if all of that works, we know that our database is working. While we're looking at this, I want to point out something to you. We talked about making our code so that it was basically database agnostic, that it didn't care whether or not we had MySQL or Oracle or whatever. But you can see our code here is actually asking for MySQL fetch array. That is definitely a MySQL thing, and if we switch databases later, that's going to break for us. And even though it's one of the methods we defined, we did the same thing up here when we said MySQL prep. We said that we would prep it for MySQL, but if we change to an Oracle database or something later, then that obviously isn't going to make sense. So let's make improvement to our object. In addition to these methods here, let's add another one. I'm going to put it right above the private method, and I'm just going to call it public fetch array. All I did was take MySQL out of it. But that way we could have an Oracle adapter which would do fetch array, and it would do it in a different way. It might have a different way of handling it. That makes it agnostic. And then all it does is return the result of MySQL fetch array on the result set. And now we just say, okay, database object, go ahead and perform fetch array on the result set. For changing MySQL prep, let's just change this now to instead be escape value instead. And we'll come back over to our database object, and we'll do the same thing. Instead of MySQL prep, it'll just be escape value. And now, escaping the value can happen in whatever way it needs to happen for whatever database we're on. There are 3 other database neutral methods that I want you to go ahead and input here as well. We aren't using them yet, but let's go ahead and put them in here so that we're ready. We've looked at them before. We've got numRows, which performs MySQL numRows and returns how many rows are in a result set. We've got insertID, which returns the last inserted ID over the current database connection, and that's MySQL insertID. We've seen that before. And MySQL affected rows, how many rows were affected by the last thing, and each time we're just dropping MySQL off the front of it. And those are going to make for nice database neutral methods. And if a database adapter needs to be swapped in so that we're using a different database, our code doesn't break. We don't have to do a massive rewrite. We've already taken that into account when we wrote our database object. So let's go ahead and save that. Let's just make sure that it's all working. And sure enough, everything's still working fine. In the next movie, we'll take a closer look at how working with this database as an object is actually an improvement over the functions that we were using before. Over the course of the last several movies, we've been able to take all of our database functions that we were using before and put them into a database class. In this movie, I want us to take a brief look at how that object-oriented programming approach is actually an improvement over just having those loose functions. Now, you probably noticed some of the advantages to using an object-oriented approach as we were going. For example, we were able to group all of our code together. So things like MySQL prep, which became escape value, those can be grouped with our database. And so all of our code for our database is in one place. We also saw how it makes the code modular, and we would be able to potentially swap in a different database if we needed to. And we were able to write methods like numRows, which calls MySQL numRows, and therefore allows our code to be database neutral. One thing that we didn't explicitly talk about, though, is that improvements made to this object are now available on every page where the object has been instantiated or where it's being called. So suddenly, by adding the method numRows to our object, anywhere in our site that we were calling the database, we now have the ability to call numRows. So any improvements or complexity that we add to our object automatically propagates out to that object every time that it's being used throughout our site. Let's make another kind of improvement like that now. Let's add a new public attribute, which will be called last query. And it will allow us to find out what the last query we tried to run was. Now, in the past, we've done this using just an echo statement, and that was a really good way to debug. Now we can actually just make it part of query. Whenever we run a query, we can just set this last query equal to the SQL. So we'll just set that value each and every time. So we can always just ask this object, hey, what was that last query you ran? And one good place that we can put that is in our confirm query method. So let's come down here to this private method, and let's just alter it slightly. And instead of just dying with this simple text and the SQL error, let's have it construct a string out of that same string, but then also add the last SQL query to it, and then die using that string. So let's save it. In order to try this out and see how it works, one easy way to do it is for us to come back over to our index page, and let's just take out these comments where we got that error before. We'll save it. We'll go back to Firefox, and let's reload the page. Database query failed. We got the same error, but now we also get last SQL query, and we can actually look at our query and see if we can figure out what was wrong with it. Now, this might be something that you only want to do in testing. Once we get to production mode, you might want to come back over here and actually just comment this out so that it doesn't get appended anymore. And that proves the point that I was talking about, that simply by commenting it or uncommenting it, it suddenly changes what happens throughout our website. It changes the way this object behaves. There's one other function that I think is ripe for some improvement. Let's jump up here to this escape value. Now, a value might get escaped on a single web page 5, 10, 15 different times. If we're pulling in a whole lot of form data, we might be doing a lot of escaping. Every single time that this function gets called, it's going to check and see our magic quote set. Does this function exist? Every single time. It occurs to me that that's wasted processing power, and we're just slowing our site down. Instead, let's take these two lines, and we'll just cut them, and we're going to just jump up to the top of the document here. So I'm just going to paste those two checks that go on right here. I'll take the comment out. I don't need that anymore. And instead of new enough PHP, I'm just going to rename it as real escape string exists. There we go. And what I want to do is set attributes equal to these. So each of these is just going to become this magic quotes active, this real escape string exists. So now what I need is to have those attributes, and I'll make them private. There's no reason I need to get to them from outside the class. And this one will just be called magic quotes active. And this one will also be private. and real escape string exists. So stop and think about this for a second. What this means is that now, down here at the very bottom, when I instantiate the MySQL database class, one time and only one time it runs the construct method, and that will check to see is magic quotes active, and it will save that value here. And it does the same thing for real escape string. So we don't have to waste the processing power checking that each and every time. Now we have those attributes that we can check. So instead, let's just copy this one because we changed the name. So now if we check that attribute and it's true, then perform the same thing. And we'll just put this in front of magic quotes active. And then here we can also put this in front of magic quotes active. So now it does the same escape of the value that it did before, but it doesn't have to waste the processing power each and every time. And back to the original point that I was making, these changes now propagate out to anywhere that we were using the object. I feel like we have a pretty good database class now. Some people like to go ahead and populate this database class with all of their database calls and everything, but we're not going to do that. Instead, what we want to do is create a separate user class, which is going to make use of the database class whenever it needs to access the database. But it can have a lot of other things that are unrelated to the database in that class as well. So we'll work on the user class in the next movie. Now that we have a pretty good database class that will connect to the database for us, I want us to write our second object, which is going to be our user class. And the user class will make use of the database class to connect to the database. And all of the information about finding users will go in our user class. Now we could put those in the database class. In fact, some developers do. But the database class might start to get quite large if we had a lot of different finds going on. Instead, since these belong to the user, they're unique to the user, it makes more sense to put them there, to group our code according to the user object. So I'm just going to open up index.php here. What we want to do is try to move these 3 lines of code into a class, so that all of that finding is handled by the class. And instead, what we'll end up with is something kind of like this. I'll just put ... for now. So basically, the found user will ask the class to do something, and it'll return the found user in one line. That's it. And then we can start to pull information like username out of it. So let's create the class and figure out how we can call it to return that found user. I'm going to create a new file in TextMate, and I'll just go ahead and save that. And I'll name it user.php, singular. And we'll put our PHP tags and class user, singular. That's the way we want to do objects, is with a singular name. If we had many of them, they would be users, but the singular version of the class is just one. And it's also a good idea at the top here to go ahead and require the database, because we're going to be needing the database so that user can make those calls. And even though back over here in index, we're still saying load the database, it's okay to do it with require once a second time, because it'll say, oh, I've already done that, and it'll skip it. But since it's a dependency of the class, it's a good idea to go ahead and have it here at the top. It's just smart programming. Now inside my class, I'm going to go ahead and paste 2 methods, which I think will look very familiar to you. The first one is find all, and you'll notice that I'm using global to pull in the database so I can work with it. We talked about global. It brings in the database variable from the global scope so that we can use it, and then I'm going to ask that database to perform a query for me. And here's my query, just simply find all from users. That returns a result set, and I simply return the result set back to whatever called this method. The second is find by ID. It's basically the same thing, except that it takes an ID. SQL is slightly different, and it goes ahead and does the fetch array on the result set. We're going to have to do that up here. We're going to have to perform fetch array each time we go through and fetch a new array. But if we're only returning one, there's only one object inside this wrapper. There's no sense in returning both the object and the wrapper. Go ahead and just take it out of its wrapper and hand back just that array that we'll work with. So I've just called it found for now. So I'll save this file. There are 2 ways that we can go about this, and I want us to see both of them. The first, I want you to notice that this right here is an instance method. We talked about the difference between instance methods and static methods or class methods earlier. This is an instance method, which means in order to call it, I need to have an instance. So before I can call found user, I've got to say user equals new user, just to have an instance of it. And then I can ask that instance, capital user, find all. That will then find that user. Or if I want to just find one, let's do that instead. That's a better example. Find by ID 1. So I've instantiated it, then used that instance to call this method that returns it. Now, a lot of times you'll see programmers do it this way. Now, there's nothing that's inherently wrong about doing it this way. If you prefer it this way, or if you're already used to doing it this way, or maybe someone else's code is done that way, it's not necessarily wrong. However, I think that the better way to do it is to use static that we talked about before and make these into class methods. A class method, the difference is that the function sticks around, it's static, it sticks around, even when we don't have an instance. So then we no longer have to instantiate it. Instead, we can use our double dot notation and just ask the class directly, hey class, run your find by ID method. And it returns the value found user, and then we can do the username on it. Let's go ahead and try that. Let's just put in a echo HR tag here, just to separate it. And let's load up Firefox, and let's hit reload. Oh, class user not found. That's because I didn't include it up here. So I'm also going to need to, of course, require once user. That was a silly mistake on my part. Let's just go back to Firefox and try again. And there we are. So if we step through what happened here, the database class was defined, then it was instantiated and assigned to the variable database. Then we define the user class. When we get down here, we use the static method to search the database to find ID 1, returns that, and then we're able to say, all right, give me your username out of your row. We can also try our find all method. If you take a look here, I'm just going to do another static call to find all, return it to the user set. We'll then need to do database fetch array on each one and return it to the value user, and then go through each one and list the username, first name, last name. You can pause it if you need more time to copy that down, but I'm going to go ahead and try it out. Switch over to Firefox, and there we are. Username K. Skoglund, name Kevin Skoglund. So with a very small amount of code in our class definition, we were actually able to clean up all of this messy SQL that was going on here and make it something nice and clean. User find by 1. It makes it really clear. It's a good narrative to our code. I'm going to make one more change here. I'm just going to paste in another function, which is find by SQL. So this will just take any SQL we send it and perform that on the database. That's a useful one to have because we might not always want to just find a single one or find all of them. We might want to find a subset. So find by SQL might come into use in that case. In fact, on your own, what I'd like you to do is rewrite find all and find by ID so that they use find by SQL. And keep in mind that they're static methods. So you want to make sure that you call it statically. And then in the next movie, we'll look at how we can improve this class further by using instantiation on the results that come back from the database. We created a user object, but so far our user object has really just been used as a way to find records in the database. And what we've been returning are arrays, just rows of data, and not really working with objects, working with them in an object-oriented way. So in this movie, I want us to see how we can further improve our code by doing that. First, let's take a look at the results of the assignment I gave you at the end of the last movie, just to make sure we're all on the same page. We introduced find by SQL as a static function, and what I wanted you to do was to modify find all so that it also calls statically find by SQL. And we can just simply return the result of that. It'll return whatever find by SQL gives us. So effectively, it's just the same, except that we're providing the SQL for it. Find by ID is slightly different. We're going to do the same thing. We're going to call it statically, but again, we're going to use that fetch array to reach in and return that first row of data out of the result set. Now this raises an interesting point for us. We're actually returning here when we do fetch array is an array. It's not an object. It's an associative array that has keys and values that represent a row in our table. Let's go back and look at index.php and see. Actually, let's go at the top here. I'm just going to delete a lot of this code. We don't need this anymore. So if you'll notice here, when I'm doing find by ID, I'm getting a found user, but I'm not actually getting a user. What I'm really getting here is a record. That's what's coming back to me, is a record or a row. So I'm going to just change this to record to make that clear. And what I really want to do is be able to work with this as an object, because we really want to be doing object-oriented programming. And the reason why is so that we can perform more complex tasks with an object than we can with just simply text that's in an array. There can be a lot of complexity built into objects. Here's a good example of that. Look down here where we have user first name and user last name. It's a very simple case, but it would be great if we could have something that was just called user full name, and it was a method in our object that would simply look at the first name and the last name and put them together for us. That's something that's very common, and we would get some benefit out of being able to just call full name and have it take care of the rest. And there's certainly more complex cases as well. We could have it put together someone's mailing address, and maybe it checks another database here and another database there while it's constructing that for us. There can be a lot of complexity behind there. Well, in order to do that, what we really want to get to is the point where we can go from a record to actually having an object, and that object would have an attribute, like username. So username would just be an attribute. So let's go ahead and add that attribute over here to our user model. So we'll just make public and then username. In fact, while we're at it, let's go ahead and put in our password, our first name, and our last name as well, so that all of those attributes are there. And let's not forget that there's one other column in our table, which is the ID column. Let's go ahead and save that as well. Basically, every column that's in our MySQL table has an attribute. So what we can do is when we bring that row out of the database, we'll just take a second and we'll assign all those values to their correct attribute. So let's save this and let's switch back over to index and let's do exactly that. We're going to need a user object, right? So we can't forget to instantiate a new object. We don't have one yet. So new user, now we have an object, and now we can perform those assignments. So I'll just do the first one here, user ID is going to be equal to the record, and we're looking for its ID in the array. Just to save us some time, I'll go ahead and cut and paste the other ones in there. Remember that you can pause the movie if you need to have a little more time, but this will then give us attributes that we can work with. Let's save this, and I'm just going to also comment this out. I can do that in TextMate with command and the /, and that'll just give me quick comments on those. You can also cut and paste it out or type them in by hand. And let's just switch back to Firefox and try it. And there it is. Now this is no longer just an array. It's actually an attribute of an object. And just so we can make very clear why that's useful, let's switch back over to our model. I'll close these up so they're out of our way. And I'm just going to add a new method here called full name. So you can take a second and copy that down, but what it's doing is checking to make sure that first name and last name are set, and if they are, it returns the two together. So I'll save that. Let's come back over to this page, and now, instead of username, let's ask for full name, and we have to have those parentheses to let it know that it's a method name. That's the difference. This would be if it was an attribute, this is a method. Let's go back to Firefox, and voila. Now, instead of doing something clumsy like this, every time we want to put together the first name and last name, we can do simply this. So this is getting us closer to an object-oriented approach. But just like before, when we had all of our raw SQL sitting here and we turned it into the find by ID method, we can take all of this and actually push it up into the object as well. An object should know how to build itself. And we can do that by creating an instantiate method. So I'm just going to cut all of that out of there and go back over to my model. I'll fold up this method, and let's make a new method. This is going to be a private method. We don't need to be able to access it outside. We'll just let the class be able to access it, and we'll make it static function, and we'll call it instantiate. And it's going to take as its argument a record. I'm going to paste all that old code in there. And of course, instead of user now, I'm just going to make it object, just so that it's a little clearer that that's what we're creating here is an object. And these are all still fine. I'll just do a quick little cleanup on it so that these rows look nice and clean. It's nice and organized then. And instead of user, I can refer to it as simply self. So create a new version of yourself, instantiate yourself, and then at the very end, once we've done assigning all these attributes, then we just say return object. That will now instantiate an object for us. Now in the next movie, we'll see how to make our find methods work with this instantiation, but I want to look at a couple of improvements we could make here first. The first is that I just want to note that we could do some checking that record actually exists and that it is an array before we start doing that. That's not a bad idea. So the second thing is that this is the simple long form approach. You can see that if we had a table that had, let's say, 50 different columns in it, then we would have to list all of those out here. And that's a little bit tedious to do. So another way to do it instead would be something that's a little more processed, a little more computer savvy. We'll loop through each of the attributes. And what we'll do is we'll just check to see, does that object have an attribute? This is has attribute. This is something that we're going to have to write. But what we're going to do is true or false, does it have that attribute? And if it does have the attribute, then assign it that value and return that value to it. And I think that's a better approach. So I'm just going to comment out the short form approach so that what we're using is the longer form approach instead. So now what we need to do is write that has attribute method. So I'm going to make it a private method, and it won't be static. It'll be a non-static method because I'm calling it on an instance. Notice that. Has attribute, and then it'll just be attribute. So this is going to require us to use a new PHP function that we haven't seen yet, which is getObjectVars. Paste it in there, and then I'll just open this a little wider so you can see. I've got some comments already included. GetObjectVars is what we're using. And what it does is it looks at this instance that we're working with, this, and finds out what are all the attributes. Now, one note here is it includes the private attributes. So just keep that in mind. It includes private ones. You can look at php.net if you want to find some workarounds so that you don't include the private ones. For our purposes right now, it doesn't really make a difference. And then the next thing we'll check is array key exists. Does the key attribute exist in ObjectVars, in the array that gets returned back? And that's going to be the has attribute function. So this will then instantiate objects, and it'll run through all of the columns that are in our table, check and see if there's a matching attribute, and if so, it'll assign that value to the attribute. And then we'll have an instantiated object because it will return the object. In the next movie, let's see how we can modify our find methods to complete this so that they will automatically instantiate objects when they're finding. Now that we've written an instantiate method in the last movie, in this movie I want us to revise our find method so that they perform that instantiation for us. And they never return rows, they always just return objects. Before we do that, I just want to correct something from the last movie, which is that I had inadvertently commented out object equals new self. We're going to need that down here. So make sure that the only thing that's commented out are these assignments. Object equals new self still needs to be in that instantiate method. So I'm going to hide those, and I'm going to just look at find by SQL to start with, since that's what these other methods use. And what we want to do here, instead of just having a result set and returning the result set, we want to take that result set and we want to process it. We want to go through each one of those rows by doing a fetch array, pull back a row, and then instantiate it. And we'll assign it to a new array. So I'm going to create an object array here. It's just an empty array. And then I'm going to do MySQL fetch array on the result set, assign it to a row, and then instantiate that row. And it's going to be a static call to instantiate because that's a static function. And the result will be an object that will just get added to the object array. And then at the end, we'll return the object array. So what we'll return is an array of objects, and our rows and our raw result set will not ever get passed back to index. We'll just receive objects. So we'll save that processing. I'm just going to jump up to find all and point out that we don't need to make any changes here. It's already just going to return whatever find by SQL returns. So there's no changes there, but find by ID is going to need to make a change because it was doing a fetch array. So there's nothing to fetch anymore. If it's doing find by SQL, that's going to return a result array to us, not a result set. It's just going to be an array that comes back. So then what we're going to need to do is still pull that object out of the array. If there's only one item in the array, we don't need to return the array, just like before. So instead, we're going to modify this slightly. And I'm going to first make sure that the array is not empty. If it is empty, we'll return false. But if it's not empty, then we'll do array shift result array. We remember array shift from chapter 2. We're going to pull the first element out of the array. We could also just return the 0 indexed element in the array, but I'm using that array shift that we saw earlier. So that's the other change we'll need to make. Now this will also either be returning an object or returning false. The reason why we return false is then we have the ability to say if it returns something. So if we got something back, and it'll be either true or false. So let's go back over here and let's just make a modification to index now so that it can make use of this. This will no longer be returning a record now. Find by ID will be returning a user, and then we can ask for that user's full name. And that's all there is to it. We've now reduced all of that code down to these 2 lines. Tell the object to find the item I want by its ID, and then tell that object to give me the full name back. All that complexity reduced down to those 2 things. Hopefully you see now why object-oriented programming is really powerful. We can make the same kinds of changes here to the user set. Instead, when we do find all, it's just going to return a set of users. So we won't be wanting to do a fetch array on that anymore. Now it's just an array that we can loop through. So we don't have to use the while loop. Instead, we can actually just put in a for each loop. So for each users, as a user, go through and output their username and their full name. Let's try both these out. We'll save it. We'll go back to Firefox. And let's hit reload. And there we go. So notice how much cleaner and more intuitive what's happening in index is now. It's a lot easier to see what's going on, and all of the complexity is pushed up into the model so that it's still accessible, but it's out of the way and grouped with everything else so we can still find it if we need it. So now that we know how to instantiate objects and have it happen behind the scenes, it's going to make it a lot faster for us to program our pages like index.php, so that they can do what we want and all the complexity just happens for us automatically. In the next movie, I want to take a slight detour and talk about the case in which we haven't actually required the model that we're looking for, and a special way that PHP provides that we can handle that. In this movie, I want to make a slight digression to talk about auto load. And I'm calling it the undeclared object safety net. And you'll see why that is. You'll see why it basically saves you if you have undeclared objects. Now first, let's see what the problem is, and then we'll see how to solve it. Let's say, first of all, that I did not have require once includes user.php. That's a necessary step for us to have user defined so that we can use it here. Let's just try loading that up without it. I'll reload the page. Fatal error, class user not found in, and it tried to find it inside this file, inside index.php, and it says it was never defined. Now, of course, if you're a good programmer, you're going to want to always use this require once. But I want to show you this safety net that can help get you around it if that's not the case. Let's open up our functions.php file. And we've got a few functions in here already. I'm just going to fold those up so they're out of our way. But we're going to add a new one. And it is this autoload function. It's __ autoload. Now that has the same format of the __ as we did for our constructors and destructors and clone, but it's not inside an object. It's just a standalone function that exists outside of an object. Now, of course, if we're going to make use of it, we've got to also make sure that we require our functions in here, functions, so that we actually have access to it. So now, autoload will have been defined. When it gets to the point where it says, oh, user, that's not defined, I have an error, it'll stop and first check to see, is there an autoload function defined? And it'll call it. And it'll ask it basically, hey, what should I do? And it'll pass in as an argument the class name that it's looking for. In this case, user, with an uppercase. So then we can provide instructions on what it should do to handle it. So I'm going to try just making some simple instructions here. I'm going to say take the class name, make it all lowercase, then put PHP at the end, see if the file exists, and if it does, require it. And voila, problem will be solved. If not, then die with an error that says the file could not be found. And in that case, when it's not found, we'll get something that's prettier than the ugly error output we got before. So let's try it now and see if that works. We'll switch back over to Firefox. The file user.php could not be found. Well, that's because we have to tell it where to find it. So in this case, this function is actually looking from index.php. So I'm going to have to put a ... space includes to get into the right directory where that class might be. So that's going to be my includes directory. That's where everything is. Let's take a look again and see if that works. And now it works fine. That's why I've called this path. This is going to be the path that it takes to get there. And we're going to work on this a little bit later. We're going to talk more about paths and we're going to refine it a little bit. But for now, this will tell everything that's in that root directory of public how to find it. Now we're going to run into a problem, of course. If we're not in the root directory, if we're in a subfolder or something like that, we'll have to have another way to navigate to this. We'll explore that a little later. But for now, I want to emphasize the autoload function and let you see that having this base function defined will tell PHP how we can handle it. Instead of user, let's just try making up another one. Let's say junk equals junk. Actually, let's make it create a new junk, which doesn't exist, of course. Let's go back to Firefox. The file junk.php could not be found. So we get something nicer than that old error message. But the main point is that that autoload function gives you a safety net for cases when it hasn't been defined yet. Now, I know you're all going to be good programmers and you're going to go ahead and define it anyway, but it's nice to have this here so that it can actually find it. And you could have several directories. Maybe it looks in 5 or 6 places to see, is it here, is it here, is it here? If not, then finally fail. It can be as complex as we want, but it lets us have the opportunity to try and sort it out before we just get an error. Now in the next movie, let's take a look at how we can build a class that will handle our sessions. Now that we have a database class and a user class, I want us to move further along towards the goal of being able to log in to an admin area by looking at the session class. Now we took a look at sessions before in the PHP with MySQL Essential training. I want us to now look at it with an eye towards making it object-oriented. So to start with, I'm just going to go to TextMate and open up a new window, and I'll save this in the includes folder, and we'll just call it session.php. And we'll start with our PHP tags, and it's going to be class session. That's going to be our session class that we're going to create. Now, if you remember back to what we learned in the essential training, the session is going to be maintained on the server as a file. And what we're going to do is actually get the cookie for the session automatically sent to us by the browser, and we'll be able to look up what file is there. And then in that file, we can store things. And that way we can actually store the user state. And that's especially useful for things like whether or not they're logged in, because we can remember, hey, this person has been logged in already because I already found their ID and I already marked them in my session file. So every request they make, we just check the session file. We don't have to go back to the database and say, look up this user, see if they exist, see if they're, authenticated, and if not, get their password and so on. We can just keep them logged in. The analogy that I used before was like having a nightclub and having a bouncer that keeps people out. But if you have a hand stamp, then you can come and go as you like. So before we get started, I just want to put a note here at the top, which is that I want you to keep in mind when you're working with sessions that it's inadvisable to store database objects in the session. You can store the ID for the object so that you can go find it again, but you don't want to actually store the entire object. And the reason why we do that is because the objects that are in the session can become stale. That is, that the database can be updated by other users on the system while the session still has an old version of it saved in that file. There also can be pretty large objects too, and that's another reason why you don't want to put them in there, is because there are large amounts of data. It's much better just to store the ID for, let's say, a user's record, and then go back to the database to get a fresh copy whenever we need something from it. So like our database class, we're going to want our session class to exist right away. So I'm going to do the same instantiation at the bottom of the file that we did for the database class. So when this loads, it'll define session, and then it will create one for us automatically. So that means that a lot of the setup that we're going to want to have happen is going to take place in our construct function. If you remember back to what we learned in essential training, the main thing we need to get the sessions rolling in PHP is session start. And if we issue that PHP command, it gets the session started. It figures out the cookie, and it finds the session for us, so that that's all taken care of. And if there wasn't a previous session, then it creates a new one. Other than including the session file in our index file, this is actually all we need to get session started. It's that simple. We basically have just said, all right, make a new session object, and when you make that object, get the session started PHP, and now we're ready. We have sessions, they're available to us, and we can start working with them here. But because it's an object now, we're going to want to have attributes so that we can keep track of things. So for example, I'm going to want to keep track of whether someone is logged in, and I'll have a flag for that. Another one is the user ID. I'm going to want to have a flag for that. Now the user ID is going to be public because I'm going to be able to ask the session for it. But logged in, I'm actually going to make private so that only the session can figure out whether someone has been deemed logged in or not. That's not something that we can change the value of on our own. So from our application, we can't just say logged in true, logged in false. Now, we certainly could do it that way so that we just handle it from outside the session. But again, we're trying to push all of the complexity about logging in and everything into this session object. So I'm going to create a new function here called ch6. And that's going to ask the session, we've already created a session, to see if the user ID is set. And if it is, then it's going to set user ID equal to that value, and it's going to make logged in equals true. If it failed to find it, then it will unset that value and make logged in equals to false. In fact, we can go ahead and say logged in equals false at the start. So now when the construction happens, it would be great if we went ahead and also just ran this method, check the login. So start the session and then find out, is the person already logged in? It works a lot like the way we did the instantiation before. We're setting these attributes based on data that we find. And then even though that's all I'm really going to do here is just establish the fact that they're logged in or not, we could have something else here that said if they're logged in, then do a certain set of actions right away. If they're not logged in, then do another set of actions right away. This is not where we're going to take care of redirecting a user to a login page or anything like that. Don't be fooled by that. We'll take care of that somewhere else. We'll do another test for are they logged in. But this is just a place where we could take additional action, and I just want to highlight that to you. Now that we have a private function for checking whether they're logged in or not, what we're still missing is a public way for us to find out whether the session succeeded or not. So it gets constructed, it marks all the attributes correctly, but then we need a public function I'm calling isLoggedIn, which will check and see, is the person logged in or not? This is like the bank teller being able to go to the bank vault. Is logged in has access to this method, but we don't directly. What this keeps us from is being able to write to this method. We can read from it here, but we can't write to it. We can't set this value in any way. Only the class session can do that. Now there's two other methods that we're going to need here, and those are going to be in the cases when someone logs in from a web page. So they enter their username and password. We want to go to the database, find the user, make sure the password matches and everything. And if it does, then we want to say, hey session, mark them as logged in now. Even though they weren't logged in when you got set up, now you need to mark them as logged in. So here's the way I'm going to do that. I'm going to write a public function called login. The database will take care of finding the user based on the username and password. If we get sent a user, then take that user ID and set that equal to both the session ID, so it'll be stored for the future, and mark it inside this object, so that the object will also be updated. And then mark logged in as true, since it was marked logged in as false, presumably before they got to that page. And that will then effectively log someone into the page. Conversely, we'll want to log them out as well, so we'll need another function here, public function log out, and it will just unset that session ID so that we don't remember it for the future. It will also unset the user ID here so that that's no longer in effect, and mark logged in as false again. So here now we have a session object that handles everything for us. When we fire up the application, it figures out whether they were previously logged in or not, and we have the ability to test whether they are logged in currently, to log them in, and to log them out, all by just issuing these three simple method commands: is logged in, log in, and log out. And now our session class will take care of the rest. Now that we've written our session class, let's look in the next movie at how we can write the actual login and logout pages to make use of this. Now that we have a session class, let's use that class in order to log into our application. Through a lot of this, I'm moving very quickly because it's things that we covered in the essential training. Remember, you can pause the movie if you want to copy down the HTML code or anything like that at any point, or you can just use your own. The first thing I want to do is I want us to go into the public folder, and I want to make a new folder inside of that folder. Actually, I didn't put it in there. Let's just drag it in. And I'm going to name this untitled folder admin. So that's going to be where all of my admin code is going to be put. I'm going to put it all in that folder. And that way it's really easy for me to try to restrict access to that folder. Index will be part of the public folder, and that'll be the public pages. Admin will be the more private pages. The nice advantage of this is that we also have the ability to just type into our menu bar the same URL /admin, and it will load up the admin index.php. So let's create an index.php for admin. I'm actually going to just option drag this one in there so that I have a duplicate of it. And I'm going to actually duplicate it one more time. I'm just going to duplicate, and I'm going to just call this one login. Now, I'm going to overwrite what's in there, but that gives me some files really quickly that I can work with. The index page, the page that we want to get to, is actually going to be a menu page. So I'm going to take everything that's here now, and I'm just going to paste over it with some new code. I'm loading in my functions, I'm loading in my session, and I actually need to go back one more directory here, ... There we go. So it goes back into the main directory, then back outside of the public, and then into includes from there. It's going to check and see, is the session logged in or not? We wrote that method. It's a method, so it's got parentheses after it. If that's not true, then redirect to login, and redirect was defined inside functions. So this will make sure that we don't have access to this if we're not logged in. But if we are logged in, then it'll go ahead and just give us some HTML, nothing special here. It just says menu on it. Notice here at the bottom for the copyright, I'm using that date function that we learned back in chapter 2. We talked about string for time, and we talked about date. I'm using date just to display the year of the current time. So the copyright will always stay current. It's a nice trick so that my site doesn't fall out of date. When it goes from December 31st to January 1st, my website will automatically update to say the following year. So I'll save that and I'll close it. That'll be enough to get us going on that page. Now what we really want to focus on though is this login page. So we have everything we had before. We have to change our directory structure slightly so that we look backwards one more directory. And we'll talk about how we can improve that coming up soon. We also need to add a new one here, which is going to be for our session file. Session. And so that'll load up the session for us. We're not going to want to do any of these steps we were performing before. We just want to get everything loaded up. Now, it's a good policy that if, of course, the person is already logged in, let's go ahead and just forward them on to that index page, that menu. No reason to waste any time on this page. Then we're going to want to have our form. Remember to give your form tag a name attribute so that we can check and see it when it's submitted. That's how we'll have a single page submission. We talked about that previously. We'll want to clean our data that comes in from the form. I'm just going to put trim on it. And then we're going to do this step here. Check the database to see if the username and password exists. That's going to be a placeholder for now. We're going to come back to that in a bit. But for now, we're going to keep going with the rest of our form. And we're going to say, well, if the user was found, then tell session to log them in. So this has got to come up with a found user. And there'll be some test we'll have to perform to see whether or not the user is found. If they are, log them in. And once they're logged in, redirect them to that menu page. If not, then we're going to display a message that says the combination's incorrect. And if the form hasn't even been submitted, then we're just going to initialize those values. Now, you can probably guess what the form below that is going to look like. I'm just going to paste it all in there, and we'll come back and look at it. It's just HTML, the header, everything pretty much the same. Staff login. We're running that output message, which is in our functions, just to make a nice, pretty output of our message. The login form, loading the same form again, login.php. Username, the value for it is going to have HTML entities applied so that it escapes any values that might be dangerous. We want to make sure we always do that on user-submitted data. And the password, and then we'll submit those. And then same thing, copyright at the bottom. And the last step is if the database connection is there, then we can close it. So that's a simple form that we're going to be using for that. So now what we need to do is find out the answer to this. How do we determine if the username and password exists? Well, we could certainly do the checking here, but again, we're doing object-oriented. We want to put that into our object. We want to ask user, can you check for me and see whether or not this username and password is authenticated? So I'll say authenticate username and password. So that's the key step here, is that we're going to say, hey, model, run your static method authenticate using username and password and give me back a found user. If we get false back, then we know that they weren't found. But if we do get something back and it comes back true, then we're going to log in the user or not. So we'll save that. Now we need to write this authenticate method. So we'll just push this aside and we'll open back up user again. I'll go ahead and collapse down these functions that we were working on before. And now right before full name, let's do public static function authenticate. And of course, it's going to be passing in the username, give it a default value, and password, which will also give a default value. So there's our placeholder for it. Now what we need to do is make it actually find the values that we want. We haven't taken care of escaping those values yet for SQL. This is a good place to do that. So we'll bring in the database from the global scope. We'll make sure that those values are okay to use. Then once they're okay, the SQL we're going to paste in is going to check in the user table and see if the username and password, if those combination exist. Now, we're not doing any encrypting on the password. We talked about that in the essential training. I don't want to complicate it here. So it's just a plain text password. You know how to do encryption if you need to do it. And limit 1. Now, the find that we want to perform, though, is just like this find by ID. If we go up here, I'm actually just going to steal all this code and drop down here and paste it in. But instead of find by that old SQL, we just want to change it to be our new SQL. So find by SQL, it'll give us a result. It should be a single person or false. If it's a single person, it will do the array shift on it. Otherwise, it'll return false. So we'll just save that, take a look at it for a second, and make sure that you understand what it's doing. It's basically saying, hey, can you find this person? Authenticate. Are they in the database? It's not actually doing anything to the session. We could certainly do that here, but we're not. We're just saying find out if they're there or not. Then over in login, if they're there, then we tell the session to mark them logged in. So we're handling it here on the page. Yes, they're there. Maybe we want to do some additional checking. Maybe we want to say, well, let's make sure that the found user has paid all of their dues or something, let's make sure they're up to date. We may want to examine that object further before we actually log them in. So we'll do index.php to get them all logged in. Now that we've done all this, let's try it. We may very well have some bugs in it. So let's open up Firefox. Now, instead of just public, we want to actually go to admin.index.php. So here's the photo gallery. Now, I'm noticing that I'm not getting my CSS. That's one bug. So let's just take a quick look here. I was asking for style sheets. I've got to go backwards one directory to get the style sheets for that. Let's see if that comes up now. There it is. So there's my style sheet. Let's go to menu and do the same thing while we're at it, because I know it's going to have the same problem. So that index.php, we're also going to need to tell it to look backwards one directory to get to the style sheets. Okay, so now we've got that done. Let's try logging in. I've got K Skoglund and secret PWD was my password. And now I'm logged in. And there it is. It's not very pretty because the menu is actually got a flaw in the HTML. Let's take a look at that real quick and fix that. Looks like I'm missing a closed div tag. There it is. Close that div tag. Now let's come back over and try and reload that page. And there we are. So now we can go straight to the index page. We don't have a log out action. We haven't written that. So we would need to do that if we want to test logging in and logging out. But we did successfully see that the first time we tried to go to this page, it redirected us to the login. Then once we entered our password, the session object took care of it and then let us proceed to the menu page. We've now successfully been able to use it to log in. Now you'll notice that in these files, I had some problems here with the style sheets being located in one place and having to change directories here again. There's a way that we can do this more efficiently and handle it better, and I want to look at that in the next movie. In this movie, I'm going to show you how it can be beneficial to have an initialized file that takes care of loading in a lot of other files, and also how to establish some path constants that'll help you out. Now, in the last movie, you saw how we had to make some alterations to this require once to put another ... in it as soon as we created this admin directory over here. And we even had problems with the style sheets and locating the right style sheet as well. We've kind of been laboring a little more than we needed to over finding some of these files. And so I want to try and clean that up a little bit. It also should set off some alarm bells in your head that we're repeating ourselves so many times by requiring these same files over and over. What it would be better to do is have one file that would initialize everything for us. And that's what we're going to do. I'm going to create a new file here, and I'll save it in the includes folder, and we'll just call it initialize.php. And I'll put my PHP tags in it to start with. Let's take all of this here at the top and we'll just copy it, move it into initialize, and hit paste. Back over here, that means I can reduce all of this down to just initialize. And at the top of every one of my pages, all I have to do is say initialize. And once it does that, it'll load up everything that it needs to load up. So already we've made it better. And if we decide that we need to take out one of our classes or add in a new class, it'll suddenly instantly become available to all of those pages if they need it. Now you may be thinking, well, I don't necessarily need all of those classes every time. So am I losing something in efficiency by loading them all in? You're losing a little bit, but PHP is very fast with loading in these classes and everything. That doesn't take very long. It takes a lot longer to do things like go to the database. So speed is not going to be as much of a concern for us as code organization, and we can break it up and modularize it a little more if we find that speed becomes a problem. We still have this ... here. We can take that out because now this is actually in the same folder, right? So we'll go through each one of these, database and user, and we actually had one more earlier, if you'll remember, which was config. And so we'll go ahead and load that in at the same time. Database was loading it in because it needed it, but I might as well go ahead and load in the config file here. Now what I want to do is come up with some definitions for some paths that we can use that'll help us to locate files easily and see how that'll help us. I'm going to start out by defining the core paths. The first thing I'm going to define is a constant for ds. And if it's already defined, then I'll make it null. But otherwise, I'm going to define it as the directory separator. That's a special PHP predefined constant. If you're on Windows, it'll be a backslash. If you're on Unix, it'll be a /. But PHP takes care of figuring out which one it ought to be when it boots up. So that'll make sure that any path that we write, we're able to use ds, and it'll work regardless of what file system we're using. The second one I want to set up is site root. Let me just make this a little wider. There we are. So if the site root hasn't already been defined, then I'm going to define it. And I'm going to define it as being the directory separator, and then users, ds, Kevin, so on, sites, photo gallery, the path to my application, basically. Yours will definitely be different from mine, so you'll want to work that out so it's the same as yours. If you're on a Mac or on Unix, you can go into the command line, and you can try and navigate to that place, to where your site is. Let's say photo gallery. And then it shows it there to me, but you can also do PWD, and that'll show you the list. That will work on Unix. You also can navigate there. You can go into the hard drive, into users, into Kevin, and so on, till you get to the path. So we're talking about an absolute file system path. That's important. It's the file system, not the web server path, but the file system path. This is for PHP to locate the files that it needs. So now, for example, I could tell it, in order to find those includes files, no matter where the file is that's asking for it, the way to get there is to go into the site root and then into includes. In fact, I'm going to be referencing those include files so often, I'm going to go ahead and make a path for that as well. So lib path is going to be the path to the library. That's why the lib is from. And I'm going to say it's the site root and then the directory separator and includes, and that's how we can find that. And then we can make use of that. Let's say lib path and the directory separator again, and config, functions, session, database, and user. In fact, I'm going to go ahead and just paste in some comments that I had pre-prepared for these, that I'm going to load in the config file first, and that's just to get all those configurations set up. Then I'm going to load in the basic functions so that everything after that can use them. Then the session and the database, those core objects, and then any of my database-related classes. Those will come last. The order is important, and if I do need to change the order, I can just do it in this file. Now notice that I can't define these in the config file if I want to also be able to use libpath here. It won't have it defined unless we've done this step up here. So just take note of that. The second thing I want to point out to you is that back over here in the login file, we can't use it here either, because when this page first loads, it has to know how to get to that initialize.php. Once it gets there, then everything gets defined and it's taken care of. But we don't have those convenience helpers for us at this point. So where does it help us then? Let's go into database.php. Here we can use that libpath.ds, and that'll make sure that it can always find the config file. I'll just copy and paste that. And let's go into functions. We have auto load. We were looking for the function earlier. Well, here's how we could find it. We can go to the libpath and then look for the class name there. That's helpful. Let's also look in user.php, and require once database can do the same thing, the libpath and the database. So we now have a common way that we can always find the library. Once we've run that initialize file, we have those paths established for us. So that makes the top of the file a lot cleaner. But what about the style sheets and everything? For that, we're going to need to establish headers and footer layouts like we did in the essential training, and we'll do that in the next movie. In this movie, I want to take the path constants that we created in the last movie and use them to help us with the layout of our site, specifically the headers and footers that'll go at the top of every page. We broke those out in the essential training, and we're going to do that again here. Now, I've already created a folder called layouts, so you'll want to create this inside your public folder, and I've put 4 files in it: header, footer, admin header, and admin footer. Now I'm going to show you just the difference between header and admin header. Let's open both those up. You'll see that really the only difference between them is this ... in front of the style sheets. And we ran into problems with that earlier. So the admin header is going to find the style sheets by going back one directory from the admin folder. That's how it's going to make sure that it finds it. Now you may be wondering why we don't just use site root here at the beginning. And that's because it won't work for us. Site root is so that PHP can locate the other PHP files that it needs to put things together for us. This is different. This is the file that's going to be served up to the web browser. This is the HTML. So it's going to be the site root. So this is relative to the site. So in this case, if we open up Firefox, we're inside the admin directory. We need to go back a directory to the public directory. Now, it doesn't matter where this photo gallery exists as long as the web server serves it up. We could be in a number of different places. So this could be www.abc.com/photogallery, or maybe even just abc.com/public. The point is that it's a relative root in the URL, and that's how we're finding it, not a absolute file path. So make sure you understand the difference between the URL root that we're working with and the file paths that we're working with. And I'm going to make one more change here. I'm just going to say admin at the top of this so that it's nice and clear that we're working with the admin area. And I'll save both of those. And the footers are exactly the same between the two. There's no difference. And I'll just open it up so you can see it. It's just the bit of HTML that was at the bottom of the file before. So I'm going to open up index.php, which is the menu file. And I'm going to go ahead and start by making this also be our initialize.php. I want to take advantage of that. And then all of this here is now going to be replaced by the template. And all of this here also will be replaced by that layout template. Now, we could just simply put in some PHP and do an include. Remember include? Include will just include that HTML file, drop it in right here. And then all we have to do here at the end is put in what we want it to include at that path, admin header.php. But since we're going to be doing this a lot, and that's a cumbersome thing to write each time, instead I'm going to make a helper that will help us to do that. So I'm going to copy it, and I'm going to go over to functions, and we'll put in a helper method here. Function, and let's call it include layout template. And we're going to provide it a template name with a default of nothing, And then we'll paste that in, the include statement that we were working on. And instead of telling it which one, it's going to be just whatever template is sent in. So now we can just use this include layout template helper. And when we call that function, and this is just a root function, it's not part of a class, then we'll be able to output that template. That'll just make it nice and easy to write. So let's try that. There we go, include layout template, admin helper.php. And we can do the same thing for the footer. Include admin template, admin footer.php. And that will take care of our header and our footer, and we can really focus on what's in the middle now. Now we could put this into a class of its own. If we had a lot of these kinds of helpers for layouts, we could roll them into a class for easy access. But right now, since there's just one, I'm going to put it in my functions file, and later I can roll it into a class if it becomes more complex. So let's save this, and let's just try all this out and make sure that it's all working for us. We'll go into Firefox. I see I've got this weird space up here at the top. I'm just going to open up my CSS real quick. I think there's right here on header H1, if I could just put in a margin of 0 on that H1 tag, close that up and reload it. There it goes. Now it disappears. So I'll leave it to you to apply these templates to the other pages that we've been working on. The important part I want you to see here is that we were able to use site root to tell it where to locate those files. Site root, inside public, inside layouts, locate the template. And we can make use of site root in that way anytime we need PHP to be able to locate a file. And it doesn't matter where it's located. It doesn't matter that if it's inside the public folder or if it's inside admin, we'll still be able to locate the layouts folder and these files from wherever we are. In this movie, I want us to understand what late static bindings are. Before I really try and explain what they are, I think it's best if I first demonstrate what problem they solve. Let's open up our user class that we created earlier. Notice how our user class has methods that make database calls like findAll and findById. Well, so far we haven't been working with any other database tables, but we will be soon. For example, we'll have a table that will store the information about our photographs and our comments. And when we do, we'll most likely want to have similar methods in their classes that will also find all photographs or find a comment given its ID. And you may even recognize a lot of these common behaviors working with databases from the Essential training, where I referred to them as CRUD. That's C-R-U-D, which stands for create, read, update, and delete. And that's pretty much the standard interactions that we have with our databases. Well, since we learned about class inheritance, we know that good programming habits tell us that we should put all of these common methods in a common class and then inherit those methods into our subclasses. So findAll will be made generic enough that it can be reused over and over by different classes. Let's start that process together. Let's have our user object extend from a new object called database object. So I'll just come up here to the top of my class and I'll say extends database object. Now we need to create that class. I'll save this for now and I'll open up a new window in TextMate and let's go ahead and just save that. And I'm inside the right place and I'm just going to call it database underscore object.php. And if we take a look at user PHP, we can go ahead and see that all of this is actually going to be the same. We're going to go ahead and require the database. We're going to need that. But the class name now is going to be database object. And we'll go ahead and just close the class for now. So now our user class will inherit from this empty class. It won't really do much for us, but the inheritance does exist. And we could have other classes that inherit from database object. So now database object is ready for us to put methods into it that will be reused by these subclasses. The one last step that we need to make sure we do is also to go into initialize.php and make sure that we load that up. So I'm just going to copy this line here and also load up database underscore object. So that'll get required as well. We can make sure that we have that as a core object ready to us before we start loading in classes like user.php. So just to prove to ourselves that this all works, let's go ahead and bring up Firefox. I'm here at my photo gallery public page, just index.php, and you can see that it goes ahead and just brings up that same information before, where it's finding a user in the database and then displaying the information about that user. We'll come back to this page periodically to check our work. For now, I'm going to hide that, and let's just go back to user and take a look at these methods that we want to move. Well, we do want to move findAll, findById, findBySQL, but authenticate and full name are really unique to user. That's not something that will be reused, but instantiate and has attribute will be reused. So let's just take full name And I'm just going to move it up here to the top. And I'll fold it back up again so it's out of the way. And same thing with authenticate. I'm just going to grab all of authenticate and move it up here out of the way. And I'm going to go ahead, just to make it really clear, I'll put here at the top of these that these are the common database methods. Okay. So now everything that's above this comment is unique, but everything that's below it is not. So let's take a look inside each of these. Find all, you'll notice that the problem is that it's looking for users. So we need to also have a way of specifying which table will be used for each model. We know how to do that. We can just put another variable here at the top. It's going to need to be static so that we have access to it in our static method, and we'll just call it table name. And we know that that's going to default to users. So I'll also, while I'm at it, go ahead and say that it is protected. Don't have to do that, but that's a good access control thing to do. And then I'll take this out, and now we can ask for self, : and table name. And we can do that again everywhere where we find users. Here it is again. Now I can't use this notation. That won't work with self. Instead, each time I have to actually break out of the double quotes and join it in there. So I've just done it again here. So select all from and make sure there's a space here. The space is important. And then after the space, self table name, and then another space after it. Let's check find by SQL. Does not make any reference to the table name. And instantiate does not make any reference to the table name. And has attribute does not. So now we've made these reusable. Let's just make sure that it still works. We just wanted to make sure we didn't break anything in that process. So I'll save it, and we'll just come back over here to our main photo gallery page, load it up, and everything still loads just fine when I reload the page. Now I want you to stop following me for a second. I'm going to do a bit more, but I don't want you to follow along because what I'm going to demonstrate next will not work, and I don't want you to get tangled up. So just sit back for a second and watch me demonstrate the rest of this. I'm going to take all of these common database methods. I'm going to cut them. I'll save that user object. I'll come into my database object, and I will paste them in here. So now, I'll just fold them back up again so they're out of the way. Now all those methods are in the database object, and they should be inherited by user. So everything should still work. Those methods should just come down into user and be available for me to use. Let's try it out though. I'll go into the photo gallery, reload. Oops, it says, well, you need table name. That was an oversight on my part. I need to make sure that I still go ahead and say protected static table name because it wants to find that table name still. Let's come back and try again. Oh, database query failed. It was trying to do the find by ID, but it came up with bad SQL. And the reason why it came up with bad SQL is because self table name was nothing. And so it tried to do select all from blank. So it created a problem. We got an SQL error. Now this is a symptom of the problem I'm trying to show you, but just to keep going, let's say we went ahead and set the table name equal to users. Now I know that's not reusable, but it'll allow us to hopefully avoid that error. Now it should have a table name. So we'll save it, we'll come back and reload it. Now it comes back and says, oh, wait a minute, you don't have the method full name. And you may think, well, that's because we didn't move full name. We didn't promote it, and that's the problem. Well, it is, but that's a little bit deceptive. The real problem is that it's asking for full name on the database object class. Notice that. That class ought to be user. That's what we're working with. We're working with our inherited child object. We should be inheriting things from database object, but we shouldn't actually be working with database object directly. We shouldn't be calling its methods. We should be calling users methods. So somehow when we asked for it to find a user and instantiate a user object, instead it returned an instance of the parent object. If we take a look at instantiate, we'll see where this is happening. It's because we have object new self. So it's returning an instance of itself. Now we would expect that that would return the user object, but it doesn't. And we can go ahead, if we were to put in user here, then it would solve the problem. It's just not reusable at that point. What we really want to be able to say to make it reusable is, well, whatever class has inherited this, create a new instance of that. So that's where our problem is. And in fact, that's the problem we were having up here with table name, was that when it was asking for self table name, it was also looking in the database object class to get its table name, not in the users class, which had a table name. So the problem in both cases is this word self. Anytime we use self in a static method, it refers to the actual object where it resides, not the class inheriting it. To put it another way, when PHP loads up the database object class, it binds, B-I-N-D-S, it binds every occurrence of the word self to the class before the user class has even been defined. The binding happens early when it's created, not late when the object is called, or what we can also refer to as at runtime. Now, as a contrast, and to make this point really clear, $this always refers to the current instance. It doesn't have the same problem that self does. But self, we don't have an instance. We're in a static method. We're in a class method. So self is always going to have this problem. Now, you won't hear the phrase much, but this could be called early static bindings. And as you can see, it presents some headaches that are really hard for us to work around. Now, there are a couple of different workarounds that we could try. The first is we could try to simply avoid using static methods at all. We would just use instance methods instead. We saw that earlier, how instead of calling a static method, we would instead define it as a regular instance method and then just create a new instance and then call the instance method on it. This is a very valid approach and one that a lot of developers adopt. I think it's a shame, though, not to be able to use static methods as they were intended. Now, the second workaround is to try and deduce the class name. And we saw earlier how we could use getClass on an instance to figure out its class name. Unfortunately, if we do that in this case, it's still going to return database object. Now, there are a lot of different workarounds on the php.net website where developers have jumped through hoops to be able to figure out what this class name is. I don't recommend them, and I'm not going to show them to you, but there are some there if you want to try them. And then the third, and I think best approach, is late static bindings. So we're finally back to where we started at the beginning to talk about late static bindings. Late static bindings is a feature of PHP 5.3. Now, as I'm recording this, that's not out yet. It's in alpha, so it's still being tested. But while you're watching it, you may already have installed 5.3, in which case you'll have these features. Instead of getClass with late static bindings, we also have getCalledClass. So we can find out what class actually called this static method. So that's going to allow us to figure out what the class name is and create a new instance of that class. The other thing that we can do is simply say static : as our scope resolution operator instead of the self scope resolution operator. So instead of self, everywhere that we were using that in our static methods, we can just use this new keyword, which is static. And again, that's only in 5.3 that we have that available. And this is different than putting static in front of our function name. This is using it as a scope resolution operator to say, I want you to make a late static binding, a binding that happens at runtime, not back when you were defined at the very beginning. So just to be clear, once you're using PHP 5, you'll be able to move all that code into database object, and everywhere where you have self, you'll simply be able to call static. And if you ever need to get the class name, you can do that by simply saying class name equals getCalledClass. And that should return the class name to you. And then we can create a new instance by simply telling it to create a new instance of the class name. Now, if you don't have PHP 5.3, which is the case for me, you're going to take all of that code and you're just going to replace it with a simple comment that says, I'm waiting for late static bindings in PHP 5.3. Now we're all set. We're ready to go with that. I'll go ahead and put my methods back in here for now. And we have placeholder inheritance in place so that all of these common database methods can just be moved over here, and we'll know how to do it once we have PHP 5.3. So if you have it and you want to go ahead and attempt it, go for it. Now, the details may have changed a little bit after it finally gets released, but at the moment, the best place to find out information about it is going to be at php.net/lsb. So late static bindings, http://www. So you can look up more information there, find out all the details, and if it changes, that's where also some of those implementation changes would also show up as well. The important thing for us now is that you understand what the issue is and understand why it won't work without late static bindings. Now we're ready to move on to the next chapter where we can talk about working with files and directories so that we can start to upload photographs.